Welcome everyone to our presentation. We are students of the University of Applied Science in Rotterdam. We are going to present the best solution to protect New York City, specific LaGuardia Airport, from sea level rise in the future. We are going to talk about the following items: the issue, height and surface subsidence, waves and storms, comparable airfields, concept solutions, and final solution. To start, let's discuss what the actual issues with LaGuardia are. The airport has issues with flooding from the East River, and due to the location of the airport, right in the middle of New York City, there is little to no room for any growth or development inland to reduce the risks of flooding. During this presentation, we will talk about the aspects of these problems and present some of our own conceptual ideas on how to solve the issues LaGuardia is facing.
LaGuardia Airport is the smallest airport of the three big airports in New York City. JFK Airport has around 62 million passengers, New York Liberty International has around 46 million passengers, and LaGuardia Airport has around 30 million passengers each year. Even though LaGuardia Airport is the smallest airport in passenger numbers, the airport and the Newark Airport have significantly more trouble with water and are more vulnerable to sea level rise.
At a 0.5 meter rise in sea level, it can be seen that the runways are already flooding. The vital infrastructure around the airport is not accessible and can be used for evacuation and transport. At 1.5 meter sea level rise, it can already be seen that the north of the airport will now also flood. The water also enters the terminal and will cause damage on the ground floor. The vital infrastructure is still accessible and can be used for evacuation and assistance. With a rise in sea level of 3 meters, it can be seen that the entire airport is underwater. The terminal is also completely flooded. What is different in this situation versus the other situations is that the surrounding infrastructure is now also underwater east of the airport. The road network the road network is closed on one side. The terminal will now be completely submerged. The people at the airport will have to go to higher floors in the terminal to keep their feet dry.
Not only can sea level rise be a problem, but also can soil subsidence be a big issue. If the underground is sinking, the water protection construction should be a lot higher. On the left map, the soil layers of New York City are shown. On this area, it shows that most of this part of New York City contains rock in its soil, and this part, the yellow-orange part, contain more of stiff soil. When we look at LaGuardia Airport, it shows that most of the layer, especially the layer direct under the surface, contains of sand. Under this layer of sand is a layer of clay. Under this layer of clay at the bottom, it is mostly rock. This rock is the same as in the picture on the left.
Besides the height and the soil subsidence, we also have to look at the water conditions. We calculated the average water level of 1 week in storm season, also known as the winter. When it's low tide, the water level is around 0.25 meters above sea level, and at high tide it's around 1.25 meters above sea level. The East River is a river with a two-way current, as you can see in the right picture. The current of the river changes a couple times a day. The chosen solution has to resist all types of weather conditions. The most important type of disaster in New York City is a hurricane. The hurricane season comes around every year. For example, the highest wind speed recorded during Hurricane Sandy was 130 kilometers an hour. This wind speed can result in high waves in the Flushing Bay. The result of Hurricane Sandy was that the whole runway of LaGuardia Airport flooded, as you can see in the left pictures. And in the whole area of New York, 14,000 flights were cancelled. If the sea level rises 3 meters, the airport will be totally underwater, but it will also affect 620,000 residents, 308,000 homes, and 362,000 jobs.
First concept solution to protect LaGuardia contained the raising of two runways. This makes the runways a sort of dikes, which protect the terminals and the other buildings on the airport. The runways should be raised by 3.5 meters to protect the airport by sea level rise. Therefore, 1.1 million cubic meters of sand will be used. If the runway has raised 3 meters, it will be difficult for the airplanes to travel from the terminal to the runway because of the 3-meter height difference. So to solve this problem, we need to build an airplane elevator to transport the airplanes. Also, we need to build a short dike to close the gap between the raised runway and the coast. The green line in the picture represents this dike.
Our second concept solution would be to create a barrier around LaGuardia Airport and its neighborhood. Our suggestion is to build a barrier consisting of dikes, dunes and sluices. For the surrounding area of the LaGuardia Airport, we suggest dunes because they are a natural way of coastal protection and are a form of building with nature. The use of dunes are a great solution that won't harm the ecosystem. The dunes will also create a better slope where the water meets the land and will be a breeding place for new life in the ecosystem. The dunes will be sufficient enough to protect against rising sea level and storm surges. We chose not to use dunes around LaGuardia Airport because it's not beneficial for this area. The function of the LaGuardia Airport is the priority and must be conducted in a safe way. Therefore, you can't have a dune which will blow sand or other debris onto the runway. Secondly, the wake created by passing ships might affect the slope of the dunes. This will have a negative effect on the structural integrity of the dune. These problems will be avoided by creating a dike around LaGuardia Airport instead of a dune. Lastly, sluices will be placed to access harbors or rivers.
For our third and final solution, we came up with the very innovative idea that we want to develop a floating runway to make sure that no matter how much the water will rise in the future, the runway will always be accessible for air traffic. This idea was already tested in Tokyo, Japan, as you can see in the picture in the top right. To make sure the planes can get from the float to the terminal, we can use a ramp with a winch, so that no matter how much difference in height, the plane will always be able to reach the terminal. The only reason this solution has not found a more global use is the cost of such a project. The enormous amount of investment means most airports won't even consider this because building on land is 100 times more economical. But we believe this will change due to rising sea levels and the limited amount of available space in New York City.
Chosen to propose a combination of concept solution 1 and 3 as final solutions. We think it is the best to raise the runways with 3.5 meters. This way, they will function as dikes and keep the rest of the airport dry. On the southeast side will a dike be built to protect the airport from flooding. For expansions will flowing runway be used. To get the planes from the lower terminals to the higher runways, there will be used a winch to put the planes up to the dikes.